Cubic functions examination questions. This is grade 12, mathematics paper 1. This discusses how to determine the equation of a cubic function when given the x-intercepts. So we have a question here. The sketch below represents the graph of f of x is equal to x cubed plus ax squared plus bx plus d, where a and b are the turning points and c is the y-intercept. The roots of f are -3, 2, and 5. The roots of a function are the x-intercepts. So the roots are the x-intercepts. These are the points at which the graph is crossing the x-axis. They are the ones that we are referring to as the roots of the function. So when given the x-intercepts, then we must use this equation. Y is equal to a factor of x minus x1, factor of x minus x2, factor of x minus x3. Then in this equation, x1, x2, and x3, those three numbers, they are the x-intercepts of the function. In other words, they are the roots that are given by the question. Then the value of a is found by substituting coordinates, any coordinates that may be given on the graph. In this case, we're not going to need this a because the equation is already given. And since the equation is already given, we are able to see that the coefficient of x cubed here is 1. And therefore, the value of a here is 1. Which means our equation is simply going to start with the 1 here. Then we replace x1, x2, and x3 using the x-intercepts that are there. Once we do that, we expand and simplify the expression. Number 2, we need the coordinates of point A and the coordinates of point B. These are the coordinates of the turning points. At the turning points of the graph, the derivative is always equal to 0. Therefore, to determine the coordinates of the turning points or the stationary points of a graph, we differentiate the equation, equate the derivative to 0, and solve for x. Then question number 3, the point of inflection. The point of inflection is the point where the graph changes its concavity from concaving up to concaving down or the other way around. To determine the point of inflection, we differentiate our expression 2 times to get the second derivative. The second derivative is equal to 0. So we equate the second derivative to 0 and solve for x. These are the 3 things that are needed in this question. To find the equation when given the x-intercepts, we put our expression in factor form and then substitute the x-intercepts into the equation. Then to determine the coordinates of the turning points, we differentiate, equate the derivative to 0 and solve for x. To determine the point of inflection, we differentiate 2 times and equate the second derivative to 0 and solve for x. The word derivative is trying to play games with me. So the derivative is 0, that is for the turning points. The second derivative is 0, that is for the point of inflection. That is the methods required in this particular question for question 1, 2, and 3. Now that we have the ideas that we need, we can go ahead and answer this question. It is vital that you study to an extent that the moment you read a mathematics question, it must be immediately possible to come up with ideas that are needed to answer the question. So number one, we have said that when given the x-intercepts of the equation, when given the points where the graph is crossing the x-axis, then we can use this equation. Y is equal to x minus x1 factor of x minus x2 factor of x minus x3. Then in place of x1, x2, and x3, we're going to use the x-intercepts of the function. Now that is what we do. So we simply substitute those three using the x-intercepts. The first one, the first x-intercept is -3. So there is a negative here. So if I put a -3, I'm going to have x minus and then another minus. That's why the first bracket is x plus 3. After that substitution, I simplify using the FOIL method. The coefficient of x squared is -4. That is the value of a. The coefficient of x is -11. That is the value of b. The coefficient, the last term, which is the constant, is 30. That is the value for d. My first question is answered. Number 2, we want to find the x coordinates of the turning points. Point A and B are the turning points. The method is you differentiate the function. After differentiating, equate the derivative to 0. At the turning points, the derivative of your function is always equal to 0. So if we do that, we're going to have this one. F of x is equal to x cubed minus 4x squared minus 11x plus d. My d is equal to 30. Then in that expression, so plus d, this is equal to 30. Then I differentiate. After differentiating, I equate the derivative to 0. After equating the derivative to 0, I solve for x. Now appreciate the importance of understanding quadratic equations, because this is a quadratic equation. So if I don't know how to solve quadratic equations, it will create unnecessary problems. Right, our question is answered because it is asking for the values of x, determine the x coordinates. If you were requested to determine the coordinates of the turning points, after calculating these two x values, you would need to find the values of y. So you replace x in the original equation with these two numbers one by one to calculate the corresponding values of the turning points. My third question, to find the coordinates of the point of inflection, the second derivative is equal to 0. Once again, the point of inflection is the point at which the graph changes its concavity. So you differentiate your equation 2 times. The second derivative that you get, you equate it to 0 and solve the equation for x. Once you get that answer, you can find the y value by substituting into the original function. In this case, we just calculated the x coordinate of the turning point of the point of inflection. So x is equal to 8/6. Should you be requested to calculate the y value, then you take this 8/6 back into the equation of the function x cubed minus 4x squared minus 11x plus 30. Then in this equation, we substitute x with 8/6. This will then give us the coordinates of the point of inflection. In this case, we are just determining the x-coordinate of the point of inflection. Therefore, our answer can end here. X is equal to 8/6. The question has been answered.